Okay, good morning class. So today we're looking at polynomials. I think today is the third lesson on polynomials. At this point we did a revision of factorization, factorizing a third degree expression. Then we went on to factorization by inspection. Okay, I gave you homework. You had exercise 3. Nope, this is exponents. So it's at the bottom of the page. Oh, here's it. Exercise 3. Doesn't it take us away, eh? So I can have space. Alright, any issues with number 1? Number 2? Any problems with number 2? No? Number 3? Yes, okay, so let's go to number 3. In number 3 we are told, given f of x equal to negative x cubed plus 2x squared minus 3x plus 3 and g of x equals 2x minus 1. Find the remainder when f of x is divided by g of x. So in other words, we said this g of x, now number 3, we said g of x which is 2x minus 1 equal to 0. So x equal to half. Not so. So we now say f of equals negative half cubed plus 2 times half squared minus 3 times half plus 3. Put that in a calculator. It then gives us this calculator normal mode. It's half. That's the last answer calculated in the calculator. So I now punch that in. So it's going to be negative answer cubed plus 2 answer squared. Minus 3 answer plus 3 gives you 15 over 80. Is that correct? Huh? Right, 15 over 80. So that's the remainder when f of x is divided by g of x. Then in 3.2 we are told, in 3.2 goes over. In 3.2 we are told, if f of x equals negative x cubed plus 2x squared minus 3x plus p, find p so that g of x becomes a factor. So for g of x to become a factor, again 2x minus 1 is equal to 0, which implies that x is equal to a half. So f of a half is going to be 2 times half cubed minus half squared minus 13 times half. No, I'm looking at the wrong point. I'm looking here. What am I looking at? Let's go again. Is negative half cubed plus 2 times half squared minus 3 times half plus p. And it's a factor, so it's going to be equal to 0. So I drop that. So part of that calculation is already on the calculator. So I will just take plus 3 away. The last answer calculated was half. So we punch it in there, we get negative 9 over 8. So this part here gives you negative 9 over 8 plus p is equal to 0. So therefore p has to be equal to. Right, where did you go wrong here, Michael? Yes? Yes?
I don't know what to do. I think I didn't understand what it meant by
You see, if they had told you f of x, which is negative x cubed plus 2x squared minus 3x plus 5, is divided by 2x minus 1. You know exactly what to do. Not so. But here they just gave you a g of x, and this is another function. It's just, the factor is just in functional notation. What's in it? It's exactly the same as we did. Any problems with number 4? No problems with number 4? Number 5?
Yes, sir.
In number 5, we are told that f of x equal to 2x to the 4 minus x cubed minus 11x squared plus kx plus 12. Find the value of k if the remainder is 60 if f of x is divided by x minus 3. So what do? We said x minus 3. Whoops. Grade 11 trigonometry. So what we do is, okay, so we say x minus 3 equals 0, so x equal to 3. So now we substitute 3 wherever we see x, so f of x equal, f of 3 is equal to 2 times 3 to the 4 minus 3 cubed minus 11 times 3 squared plus k times 3 plus 12. Let's find the value of k if the remainder is 60. So in other words, that is f of 3 is equal to 60. That's what we need to know. So we drop that. So I'm going to work out everything on the side. And I'm going to add that other than 3k. So that's going to be 3k. So here is good. Now I'm not going to put 3 as an answer. So it's just one button I'm pressing. So it's 2 times 3 to the exponent 4 minus 3 to the exponent 3 minus 11 times 3 squared plus 12. That gives me an answer of 48. So 60 minus 48 is 12, I think. Um, 60 minus 48 is 12 divided by 3 is 4. So k is equal to. So that means to say if I put a 4 here by k, okay, and I divide that by x minus 3, or substitute 3 where I see x, you'll see you'll get the remainder of 60. Okay. In problems number 6? Yes? Oops. Oops. Wat gaan aan vandag? What must be added to 2x cubed minus 5x squared minus 12x minus 4? So it's exactly divisible by. So it must be exactly divisible by. So if you then say 2x cubed, this is now number 6. This is the line of the board again. Two x cubed minus 5x squared minus 12x minus 4. What must be added? Let's say k. k is what must be added, so that it's exactly divisible by x plus 2x plus 1. So what do I do with that? What do I do with 2x plus 1? Sorry? Let it equal to 0. So I say 2x plus 1 equals 0. So x is equal to negative half. So if I substitute that into here, it's going to be 2 times negative half cubed minus 5 times negative half squared minus 12 times negative half minus 4 plus k should give an answer of 0. Why 0? So it will be a factor. So what I'm going to do is I'm going to punch this thing into the calculator. Again, here I'm going to use the answer button. Why? Because we type negative half whole time. It's going to become tedious. So we put the negative half equals. So that's going to be the last answer calculated. So I say 2 answer cubed minus 5 answer squared minus 12 answer minus 4. They give you an answer of a half. Not so? So k plus half is 0. So k is equal to negative half. So negative half must be added to that expression so that 2x plus 1 will be a factor of that given expression. Any issues with number 7? Yes, it should have been a problem. You had problems with the others. It says determine the value of the values of a and b if x plus 1 and x minus 2 are both factors of the expression x cubed plus ax squared plus x plus b. So if x plus 1 is a factor, then what do we do with that? Firstly, we say x plus 1 is equal to 0, so x is equal to negative 1. We substitute negative 1 into the expression, which is negative 1 cubed plus a times negative 1 squared plus negative 1 plus b, which should give me an answer of 0. Why? Because that is a factor. Okay. So this will simply be negative 1 squared is positive 1, so it's a. Then I take everything over, so it's minus b. Negative 1 cubed is negative 1 minus 1. What's negative 1 minus 1? Take it over, becomes plus 2. And this equation 1. Why am I going to simultaneous equations? Because there are 2 unknowns that you need to solve. You guys understand? So let's go to the other side. So x minus 2. So what do we do with that? We say x minus 2 is equal to 0. So x is equal to 2. Okay, let's move this here. So what we do is wherever we see an x, we put the 2. Remember that x minus 2 is also a factor of this expression. Can you see that? So it's going to be 2 cubed plus a times 2 squared plus 2 plus b is equal to 0. So this would simply give us 4a. That's going to give us 8 plus 2 is 10, not so? Plus b is equal to 0. And this equation 2. So what can be done now? Now it's simultaneous equation. So you're going to substitute equation 1 substitute equation 1 into equation 2. Okay. So wherever we see an a, we replace it with minus b plus 2. It goes in. So it's 10 plus 4 into minus b plus 2 plus b is equal to 0. Which now gives us 10 minus 4b plus 8 plus b is equal to 0 minus 3b is equal to negative 18, b is then equal to 6. So So what we do with that? We sub that back into equation 1. Why? Because you already have A as a subject of the formula. So A is simply going to be minus 6 plus 2, which is negative 4. Okay, so A is negative 4 and B is 6. Okay. Then we went on to factorization by inspection, not so? Okay. So what I'm going to do is I'm going to redo this one here. Now we were doing it on the way out. I was going to redo it, okay? If you had missed something, I'll just clarify it at this point. And I'm going to do number 2 afterwards, alright? Example 1 on page 137. When factorizing a cubic or third degree polynomial using division by inspection, follow these steps. Number 1, test for a linear factor. So how do we test for a linear factor? We test for a linear factor by substituting 1. If 1 doesn't work, we'll give you any number other than 0. Then we test minus 1. If minus 1 doesn't work, we test 2. If 2 doesn't work, we test minus 2. If minus 2 doesn't work, you test negative 3, then negative 3, and then 6 and negative 6. Okay? That is the order. It could be that none of that are factors, but at this level in grade 12, one of those must work. Okay, for an expression in the form of ax cubed plus bx squared plus cx plus d, or an expression in that form, one of those numbers we make sure works for that expression. Okay? So let's go. So we test, we're going to test for 1 first. So we got f of 1. Wherever you see x, you put a 1. 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. Alright, so that gives you 0. Not so. Then what do we say? Therefore, x minus 1 is a factor of the expression. Okay, now I put the f here. Normally they say f of x is equal to that, no? So what did I put thereafter? I said f of x is now equal to, which is x cubed minus 2x squared minus 5x plus 6. The first, your linear factor is x minus 1. Then they said we must use the division by inspection to find the quadratic, which is ax squared plus bx plus c. So the question I asked you guys, go a bit slower here again. The question I asked you guys was, x multiplied by what is x squared? X cubed, sorry. It was x squared. Okay? Negative 1 multiplied by what is positive 6? Negative 6. Okay? So the middle term. Okay, as I indicated that the negative 5x will fall in place because that is a factor. So it's either you do your factorization by inspection on the negative 5, or you do it on the negative 2x squared. I do it on the negative 2x squared, okay? On the second term. So we say, okay? To get an x squared, the only way I want to get an x squared, if you multiply an x with an x, I get the x squared. Or a constant with an x squared, I will get an x squared. Not so. So, negative 1 times x is negative x. You all agree with that? But what do I need? What do I need? Yes? Yeah, no x squared. Yeah, thank you. So negative 1 times x squared is negative x squared. We are looking for negative 2x squared. So the question you ask yourselves, what must be added to negative x squared to get negative 2x squared? So we ask ourselves, what must be added to negative x squared to get negative 2x squared? So to solve that, we take that over the equal sign. So it's negative x squared plus x squared, which is negative x squared. So you take this negative x squared and you divide it by this number here always. Okay? So it's negative x squared divided by x is going to give you minus x. Okay? Now, of course, this becomes a trinomial. In this case, this trinomial can factorize as well. So it's x minus 1 into x plus 2 x minus 3. Okay. That was the sum of yesterday. Then I gave you the other sum to try for homework, no? Is that correct? Right. Number 2. Example 2. When factorizing third degree polynomial using division by inspection, follow these steps. So the first step is test for a linear factor. So what was your linear factor here? Huh? Okay, so let's test for 1 first. 1, so it's 2 times 1 cubed plus 1 squared minus 13 times 1 plus 6. So that gives us 2, 3 minus 10. So that one doesn't work. It's not 0. Then we said you want to test for minus 1. You say f of minus 1 is equal to 2 times negative 1 cubed plus negative 1 squared minus 30 times negative 1 plus 6. It's going to give you negative 2 plus 1 plus 13 plus 6. Not 0. Okay. But this we don't have to put, you don't have to write this one out. Okay. Do it on the calculator. Not so. So 2 is going to give you 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. That's going to give you 8 is 16 plus 4 minus 26 plus 6. That gives us 0. Is that correct? Right. So that's the one I leave right now. Alright. So what do I say thereafter? Therefore, x minus 2 is a factor, okay, of f of x. But sometimes I don't give you f of x, so you don't have to say it's a factor of f of x. Okay? You all okay with that? Any confusion? No. So now, what was it? F minus x minus 2, no? So therefore, your first factor, your linear factor is x minus 2. Alright. So x multiplied by what is 2x cubed. You write that answer in there? Or you did it already, sorry. X multiplied by what is 2x cubed? 2x squared. Negative 2 multiplied by what is positive 6? Negative 3. Okay. So we ask ourselves, okay? We must end off with what? We must end off with 1x squared, not so. The only way I'm going to get that is by multiplying a constant by an x squared or an x by an x. That's how I get x squared. Not so. So, what's negative 2 times 2x squared. Negative 4x squared. So the question you ask yourselves, okay, what must be added to negative 4x squared? This is what I'm working out now. Eh? What must be added to negative 4x squared to give me an answer of x squared? You take it over. So what must be added? What? 5x squared. So what do we do with that 5x squared? You divide it by this number here. So 5x squared divided by x is going to give you 5x. So what do you notice here again? It is a trinomial, and this trinomial can factorize, not so? That will simply be x minus 2. This factorizes into 2x times 3 is 6, minus 1 is 5. These are factorized. Okay. Any confusion? Yes?
So you said 5x squared is divided by x.
Yeah. It was, why? Because x multiplied by 5x is going to give you 5x squared. Can you see here? Is this here multiplied by that gives us that. That is why I say 5x squared must be divided by that to end up with that. Okay, is there that link between it? Any other confusion? Which page is this on? 137. For homework, I want you guys to do exercise 4. We do 1 point in number 1 is the odd numbers. And number 2 is the odd numbers. Okay. Your next heading, solving third degree polynomial equations. Okay, so solving third degree polynomial equations. So what have we done thus far? Thus far we looked at factorizing a third degree polynomial expression, not so. So what's the difference? If you are given x squared minus x minus 6, to factorize that is simply x and x, 3 and 2 minus plus. So that is your quadratic equation factorized, not so. So if you ask you to solve the quadratic equation, then the difference is you got x squared minus x minus 6 equal to 0, gives us x minus 3x plus 2, and we go a step further, we get the roots. So x is equal to minus 2 and x equal to 3. Not so? So that is factorizing, and this is to solve the difference. So I take that into account and I go to what we have dealt with before. Then if the question was to the one that's already factorized, I think the very last one's the only one. Yeah? So if this was an equation, then that would have simply been equal to 0 there. That would have been equal to 0. That would be equal to 0. And to solve the cubic equation, that would simply be x is equal to 2, or x is equal to a half, or x equal to minus. You guys understand? So that's the only difference now with the next part of the work. Okay? So let's read what they say. Just take this out here. Oops. Alright, solving the third degree polynomial equation. In topic 8, you will learn to plot the graph of a cubic with third degree function. Okay? Which is the next topic. You will find the x-intercepts of the graph. This means you must be able to solve the equation of the type ax cubed plus bx squared plus cx plus d equals 0. What type of equation is this? This is the cubic function. That's the equation we are working with, or the equation of the function we are working with currently. Not so. Right, you will have seen that the cubic polynomial has 3 factors. A cubic equation will therefore have 3 solutions on the graph and will have 3 roots. It could have a maximum of 3 roots. No? Later on you'll see that sometimes it only has 2 roots or 1 root. Okay. A cubic equation will always have at least 1 root. Okay, that's a given, it must have 1 root. The other 2 roots may be real and irrational, or real and rational. Okay? And it could be non-real as well. The cubic equation may have 1 root if the solution to the quadratics are non-real. That's exactly what we just said now. In the graphs below, graph A has 3 roots. So let's look at graph A here. Graph A has 3 roots. 2 are equal. Can you see that, people? Graph A has 1 roots. What are roots? Roots are x-intercepts. Not so. So here you can see there's 2 roots. As I, you see it's 2 roots. Well, it's 3 roots of, and this one here has a 2-in-1 solution. Okay. 2 roots of which are the same. In B, it has 3 roots and all are unequal, it's all different. C has 3, graph C has 3 real roots that are all resulting in x-intercepts. In one x-intercept. Graph C has 3 real roots. That's not right. These are 3 real roots. Okay. This has 1 root. Oh, I see. Now, this graph here, got the dimension. Let's say that was -1. Then this would have been x plus 1 cubed. This is this type of graph here. Okay? So when the turning point and the x-intercept is the same, then that is the case. It's going to happen. Okay? So yes, it's correct what they're saying here. The graph of C has 3 real roots that all resulting in 1 x-intercept. It's all the same value. Graph D, let's move this up here. Graph D has 1 real root and 2 non-real roots. Can you see it? It only cuts the x-axis once. It is not turning on that axis. Okay, but this here, they won't ask you how many roots at all. It's just explaining what's happening. But that we'll do more in the next chapter. Now we're looking at the worked examples on page 138. Worked examples on page 138. The question says solve for x and in each case say what type of root the polynomial has. Okay? Solve for x and in each case say what type of root the polynomial has. So let's look at the first one. Okay? So we got x cubed minus 2x squared minus 4x plus 8 equals 0.
Good morning. May I have your attention, please? The following learners can please come to the office for a collection. Caesar Zipo, Zita, Uyanda Chambo, Kelsey Julius, Onele Mpefu, Tandeka Lata, Mabalentle Kumeni, Bianca Mbande, Maya Sukunla. Those learners, if you can please come to the office for a collection. And listen carefully, we have a special announcement.
Hi there everyone. The grade 11s have an exciting announcement to make. We will be selling delicious foods at an affordable price in the passages of the quad. And to those who are wearing costumes, please make your way to the quad to take some pictures for our Instagram page. Thank you.
Okay, so let's do this quickly. So here we're going to factorize. We're going to solve for x. Here we don't need to test because here we have a common factor. So we take out the common factor of x squared, so it's x minus 2 minus 4 is a common factor in the next set of terms. So it's going to be x minus 2 equals 0. If x minus 2 is common, I'm left with x squared minus 4 is equal to 0. This is difference of 2 squares, not so. So it can become x minus 2, x plus 2, x minus 2 equals 0. So what are the solutions? X is equal to 2 or x is equal to minus 2. This one is, and that is the same, so I'll write it 1. Okay, are you all okay with that? Let's look at number 2 quickly. Number 2, I would use that factorization which I did now in the previous 2 examples. So I'm going to test for a factor, so I test for f of 1. If I put 1 in here, which is going to give us 2 minus 5 is minus 3, minus 4, it's going to give you 2. So the 1 doesn't work. Go minus 1. So it's 2 times negative 1 cubed minus 5 times negative 1 squared minus minus 1 plus 6. So it's negative 2 minus 5 plus 1 plus 6. So that gives us 0. Not so. So what can I say? I can now say that therefore x plus 1 is a factor of, what is a factor? Huh? F of x is not given. So the sum was 2x cubed minus 5x squared minus x plus 6 equals 0. There you go, x plus 1. So x multiplied by what is 2x cubed? 2x squared. 1 multiplied by what is positive 6? Plus 6. Now coming back to this here. 1 multiplied by 2x squared is 2x squared. What must be added to 2x squared to give you negative 5x squared? That's the question you ask yourself. What must be added to 2x squared to give you negative 5x squared? And what is the answer? Negative 7x squared. So what do I do with this? I divide it by x, which gives me an answer of negative 7. You all agree with that? What do you notice here? What do we have here? What is this, eh? Trinomial. Not so. So you can factorize. If you can't factorize a trinomial as it stands there, you can use the quadratic formula. Or if you've got this calculator, you might like it easier. So it's 2, negative 7 and 6. So the x value is going to be 2. So it's going to be x plus 1, x x minus 2, and 3 over 2. This gives you 2x minus 3. Okay. So in other words, x is equal to negative 1, or x equal to 2, or x equal to 3 over 2. You guys understand? Any confusion? No. Now later on you'll see that the quadratic equation, the next one probably gives you irrational roots. Not so? And the next one could give you non-real roots for argument's sake. It's exactly the same. Okay. People, part of your homework. It's going to be exercise 5. Okay? You do me exercise 5. You do me the odd numbers in. People, enjoy the rest of your day and your weekend. Good morning, class.